In this video, I'm going to go through the IXL skill, write a quadratic function in vertex form. The equation of a parabola is y equals x squared minus 8x plus 15. We're going to write the equation in vertex form. Now, I want to remind you that vertex form is the form y equals a times x minus h squared plus k. And right now, we have this parabola y equals x squared minus 8x plus 15. This is in standard form, that ax squared plus bx plus c. If we're going to turn the standard form into the vertex form, we're going to have to complete the square, which what we have right now, this equation, y equals x squared minus 8x plus 15 is not a perfect square. This equals y equals x squared minus 8x plus 15 is not a perfect square trinomial. So completing the square, when we've looked at this before, we've moved the old c value over, and you absolutely can do that here. There's also kind of another way you could approach this. And essentially what we're going to do is we're going to add in this new c value. Let's kind of shift everything over. So we have y equals x squared minus 8x, and then we're going to add in this new c value. And then whatever we add in, let's just also subtract the same value, because if we add and subtract the same value, then that's going to add to 0. And then we have the plus 15. So what is this number that we need to add and subtract? Well, that would be the b over 2 squared. And our b value is -8. So we have -8 divided by 2 squared. -8 divided by 2 is -4 squared. And -4 times -4 is positive 16. So we're going to add 16 and we're going to subtract 16 because 16 minus 16 is 0. So we haven't really changed the equation at all. We've just rewritten it in a different way. And now this x squared minus 8x plus 16, this is a perfect square trinomial because we added that perfect square constant in. So this is going to factor into x minus that b over 2. It was negative, so that would be -4 squared. And then we'll add -16 plus 15. -16 plus 15 is actually the same thing as 15 minus 16, or -1. So we have x minus 4 squared minus 1 is equal to y. And that is our equation in vertex form. All right, here, y equals x minus 4 in parentheses squared minus 1. And remember, this x minus 4 in parentheses squared is the same thing as x minus 4 times x minus 4. And if we remultiplied out x minus 4 times x minus 4, we would get that x squared minus 8x plus 16, that perfect square. All right, so let's submit. The next problem I'm going to look at is actually on this page. So the equation of the parabola is y equals x squared, or sorry, the equation of a parabola is y equals x squared plus 8x plus 16. We're going to write the equation in vertex form. This trinomial actually looks a little bit familiar. We just saw one that kind of looked like this with the 8x as the middle term and the 16. This is a perfect square. Remember that perfect squares fit that a plus b squared, and when you multiply a plus b times a plus b, you get that a squared plus 2ab plus b squared. So I recognize here this 16, that's the b squared. And if we take the square root of 16, that would be 4. And 2 times 4 is 8. So 2 times 4 times x, that 2ab middle term is there. So this one actually pretty straightforward. We're just going to factor this perfect square trinomial. This is already a perfect square, so this is just going to turn into y is equal to that factor squared, and it's going to have a plus sign since the middle term is positive. And it'll be x plus that b divided by 2. So that would be 4. So undoing this 2ab dividing b by 2, we get 4. And you could also look at this as factoring x squared plus 8x plus 16, where we're trying to find those numbers that multiply to 16. multiply to 16 and add to 8. Add to 8. And 4 and 4, you multiply 4 times 4, you get 16. If you add 4 plus 4, you get 8. So this equation in vertex form would be y equals x plus 4 squared. All right, next one is going to be a little different. Let's do this one. The equation of a parabola is y equals 2x squared plus 4x plus 8. Write the equation in vertex form. So looking at this, this has now an a value. So y equals ax squared plus bx plus c. And there is an a value, this 2. And all of the terms actually are divisible by 2. So let's take this y equals 2x squared plus 4x plus 8. And let's factor out a 2. So I'm going to divide all of these terms by 2 essentially. So 2 now on the outside of a set of parentheses. And what we have left over is x squared plus 4 divided by 2 is 2x, and 8 divided by 2 is 4. So x squared plus 2x plus 4, with that 2 being multiplied to it, is equal to y. Now, let's look at this x squared plus 2x plus 4. That, unfortunately, is that a perfect square trinomial? I don't think so. I don't know how I would factor it, what I would factor it into. It's not x plus 1 squared. So I am going to see if I can complete this square. Now, we already have a 2 being multiplied to everything. So I'm going to kind of rewrite this off to the side here as y equals 2 times this x squared plus 2x, and then we're going to add in this new perfect square value, and then we'll also have to subtract it, and then we have this plus 4. So we'll switch back to. So what would that perfect square value have to be? Let's take our b value. Let's see, I'll do it in green. B divided by 2 squared. Our current b value right now is 2. So 2 divided by 2 squared. 2 divided by 2 is 1 squared, and 1 squared is 1. So I'm going to add 1, and I'm going to subtract 1. Now here's where it gets a little bit interesting, right? Because I have a 2 being multiplied to everything, right? But I want just the x squared plus 2x plus 1 to be grouped together as a perfect square. So at this point, I'm actually going to redistribute this 2 that was back out front. I'm going to redistribute that to this outside -1 and outside 4. Really, if I wanted to, at the beginning, I could have just factored the 2 out of the 2x squared plus 4x and had this old c, since it wasn't a perfect square, have this old c hanging out outside to begin with. So let's kind of rewrite this. We have y is equal to 2 multiplied by this perfect square, x squared plus 2x plus 1, which we've completed. And then outside of that, we're just distributing the 2 back. So this is going to be minus 2 times 1 plus 2 times 4. Just redistributing it back out. You absolutely could have added these together first and then distributed it. I don't know why I wanted to do it this way, just to make it more difficult, I guess. So let's see, -2 times 1 is -2, and 2 times 4 is 8. So we have -2 plus 8, which is 6. So we have y is equal to 2 multiplied by this perfect square, and this perfect square, x squared plus 2x plus 1, is the same thing as x plus 1 squared. So this looks a little bit sloppy, kind of how I have it written down at the bottom. Let's change this plus 6 so it's a little bit closer. So the final answer in vertex form should be y equals 2 times x plus 1 squared plus I don't know why I wrote down 8 plus 6 because we added -2 plus 8. I'm going to test my work. I'm going to put this in Desmos and test the original answer. I think I already have something in there, maybe. Yeah. All right. So I know it's kind of messy, but I need the writing here. Y equals 2x squared plus 4x plus 8. And then y equals 2 times x plus 1 squared plus 6. And you'll notice if I test these two answer options, ooh, I'm trying to get the green to go away. There we go. The green and the blue are the same exact line. So that's how I know I did this correctly. So again, you could have just removed the 2 from these two terms first, the 2x squared and the 4x, and then just kind of kept the 8 outside. And that would have been a totally fine method. All right, let's see. Y equals 2 times x plus 1 squared plus 6. Oh, I was on the wrong page. I was on the wrong page. Oops, that is so my bad. It was this one. Hee hee. So y equals 2 times x plus 1 squared plus 6. I thought it looked kind of funky. All right, well that's fun because I wanted to do that problem. So let's see if I can get one that was similar to it. I bet I can't. Yeah, because that's like a really fun problem, as you can see. Well, you know what? Let's just look at, see if I can't refresh it. Yes. All right. The equation of a parabola is y equals negative x squared minus 13x minus 18. So when you have this a value in front, we have a -1 essentially in front of the x squared. I'm going to factor that out of just these two terms. We'll start with just those two. So I'm going to take this negative and I'm going to divide both the negative x squared and the negative 13x by -1. So I'm going to have -1 outside of x squared plus 13x. When you divide by a negative, the signs just flip. And then we have that minus 18. We did not remove the negative from that. And then I could just obviously redistribute the -1 to get the original expression, right? So this is totally fine. Now let's complete the square I have in here. So we have y equals -1 times this x squared plus 13x, and then I'm going to add in a new c, so then we'll also have to subtract this new c. And then outside of all of that, we have the -18. Okay, what would our new value be? So we're going to take b, we're going to divide it by 2, and then we're going to square it. And b is 13. So we're going to do 13 divided by 2 squared. And 13 is not divisible by 2, unfortunately. So I'm actually just going to rewrite this as 13 squared over 2 squared. Just apply the exponent to the numerator and the denominator. And 13 times 13 is 169. And 2 times 2 is 4. And that's just an improper fraction. That's how we're going to leave it. So I'm going to add 169 over 4, and then I'm going to subtract 169 over 4. Feels awful, but really those two do add to 0. And before we focus on the perfect square piece, let's distribute the -1 to this extra 169 divided by 4, the -169 over 4. So that way the -1 is just being multiplied to the perfect square. So whatever is extra needs to be moved outside of it. So I'm going to distribute the -1 to this, and we're just going to leave everything else inside. So it's y equals -1 times x squared plus 13x plus 169 divided by 4. And now outside of this, if I'm multiplying -169 divided by 4 by -1, it's now going to be positive 169 divided by 4. So positive 169 divided by 4 minus 18. Now, that is a number. So let's just treat it as such. I'm going to go into my calculator and I'm going to, in a new line, just type 169 divided by 4 plus 18. And it's 60.25, meaning 60 and 1/4, which we can write that as an improper fraction. Desmos can as well. Notice off to the side, this little fraction button. This is the same thing as 241 over 4. So we have y equals negative, I'm just going to write it as negative, x squared plus 13x plus 169 divided by 4. And then outside of that, we added, or really subtracted, 169 divided by 4 minus 18, and we got 241 divided by 4. And it was positive, correct? I want to make sure. Oh, well, I was supposed to subtract and I didn't. Ah, that makes a difference. See how easy it is to make a little mistake? It happens all the time. So I should have subtracted, right? It was positive 169 divided by 4 minus 18. So we should have had 97 over 4. Change that. Quick fix. And now we'll factor that perfect square, right? This is a perfect square trinomial, which means it's going to factor into that binomial squared. X plus whatever your b divided by 2 was. 13 divided by 2 is just 13 divided by 2. So we have y equals negative x plus 13 divided by 2 squared plus 97 over 4. I love these ones. I think it's so much fun that it turns into all of that. So y equals, hello? There we go. Y equals negative x plus, now I need the fraction, 13 over 2 squared plus 97 over 4. Oh, and I'm going to need a fraction. So I'm going to highlight that and then type the fraction, and it'll keep it in the numerator. Pro tip. I was a little nervous there. I wasn't going to lie. A little nervous. And then look at that. It gives us one that's a perfect square right after that. So anytime you have a perfect square, that one just factored as a perfect square trinomial. This one's going to be y equals, I can tell it's a perfect square because I take the square root of 9 and I get 3, right? And 2 times 3 is 6, which is our middle term. So this is just x plus 3 squared. That was a good one to end on. Alrighty, y'all. Please let me know what questions you have. I will see you soon.